So guys, welcome back to the channel Electro King, and in this video we will see which type of batteries we should select for our electric vehicle. There are lots of variety batteries available in the market: lithium ion, lithium phosphate, lithium polymer, hydrogen. Then solid state is not available right now, so but still we are taking in consideration because it is said to be the future of the battery in EV segment. So let's see the working of lead acid battery. Operating temperature -42 plus 55 degrees, so you cannot use this type of batteries in harsh climate. Life cycles, you get really low life cycle. 1000 life cycle is the maximum. You will never get a 1000 life cycle of this type of batteries. Max to max you get 600 or 650 or 700 life cycle. You get charge and discharge. Efficiency maximum, max to max you will get around 85% of efficiency. And depth of discharge, you just have greater than 50% of depth of discharge. Maybe like you can just go 60 to 70% of depth of discharge. So you cannot discharge this type of batteries to full extent 100% discharge. If you do, you are going to actually destroy the batteries. So repairable, no, you cannot repair this type of batteries. There is a repairing process available, but it is very complicated process, so it cannot, this type of batteries cannot be repaired. But why this type of batteries should not be considered as for electric vehicle power supply system? The reason is the operation temperature, depth of discharge, repairability, no repairability. Efficiency is very important, because if you have a really good efficiency, you are going to get a good range. So efficiency is one of the most important point in this type of batteries. And the important point, the most important point greater than the efficiency is the life cycle. You get very low life cycle, maybe 600 charge and discharge, and then you have to throw this type of batteries and buy a new batteries. So this type of battery is not used in electric vehicle because of this reason. But the advantages in this type of batteries, we get a high power and they are inexpensive. You can achieve a really high power from this. You discharge rate is very high in this. You can easily discharge the batteries at 100 amps maybe, and you are going to get the full output. That is the reason this type of battery is used in car for ignition system. When you ignite the engine, the battery provide a good amount of current, and then you get a sparks, and then the car is on or the bike is on. This type of battery is used in this type of cases. They are safe, yes, they are very safe. This type of batteries are very safe. These type of batteries never catch fires. They are reliable because they are safe and they are reliable. But the disadvantages are low specific energy, poor cold temperature performance, and short life. Short life is the one of the most important point you have to consider while designing electric vehicle, because I don't want to change my bike every 6 months, maybe 6 months or 1 year. I just want my battery to last for 5 to 6 years. So that is the reason you cannot actually use this type of batteries. If you are using, then you have to change the batteries every 6 months. So let's go to the next point or the next slide and see about, let's see something about the lithium ion battery. This type of batteries are widely available. They are widely used in electric vehicles. Even you see maximum, let's say Ether, Ola, even the Tesla use lithium ion batteries. 18650 batteries are used almost everywhere. Why? The reason is here. You can use this type of batteries with the temperature of -20 degrees to 60 degrees Celsius. Actually it goes higher than 60 degrees or 65 degrees maybe, and goes from -40 degrees. So you get a very good working temperature of this type of batteries. Life cycle is really amazing. You can go around like 5000 life cycles, maybe 5000 times you can actually charge and discharge this type of batteries. So you get a really good life cycle in this type of batteries. Another thing, efficiency, you get max to max you get 95% of efficiency in this type of batteries. So you have a higher efficiency, so you're going to get your calculated range in this type of, if you're using this type of batteries. Depth of discharge, you can discharge these batteries up to 80 to 95%. So you get a really good range because of depth of discharge. Repairability, yes, you can repair this type of batteries. If any of the cells, for example here you can see series and parallel, if any of the cell is not working in series or parallel, you can actually check the voltage of the particular row or a column, and then you can remove the battery, and then you can change a particular battery which is actually not working. Internal resistance increase, that is the reason this type of batteries generate lots of heat, and then they actually discharge a complete row. So you can actually repair this type of batteries by identifying which battery is uh, got damaged, and you can change the battery. So it require external BMS, battery management system, which actually take care of the charge and discharge and the current protection. So you can use this type of circuit, and you can increase the what you say, damage or fire protection system. So by using this type of circuit, you are protecting the batteries. Even you can increase the life cycle by using the BMS. Okay, then let's come to the advantages. What are the advantages of this type of batteries? So they are used widely everywhere. You will find this type of batteries, even in the consumer electronics, cell phones, laptops, and they are used. The reason why, because of the life cycles and even the power density. They have really good high power density. Okay, power to weight ratio is really high in this type of batteries. High energy efficiency, good high temperature and low temperature performance. They get low self discharge. Okay, they can charge up to 100%. You can charge this type of batteries 100%. Almost all the batteries get charged to 100%. And the depth of discharge is around 80 to 95%. Efficiency you get around 93%, and life cycle is more than 2000. It goes to 5000, 6000. Even I have seen cells for example LG and Samsung, they provide around 3000 to 5000 to 6000 life cycles. So they are amazingly good, and they can be used for electric vehicles. So I personally use this type of batteries in my electric vehicle projects. I will be showing you lots of projects I have designed and built using lithium ion batteries. Lots of electric vehicles I have designed, so I will be showing you the batteries also how I had designed. So that is the reason this type of batteries are used widely in the market. Let's jump to the next type of battery. That is, okay, before that we will see the discharge cycle of this type of batteries. So here is the comparison between lead acid and lithium ion battery. So in just, you will see here, in just 40 to 80% there is a 6 volt drop, and if you see in lithium ion, in 40 to 80% you just get 0.5 volt of drop. So you can imagine how long this battery is going to last. You are going to achieve your calculated range because of the high efficiency. So let's jump on to lithium phosphate. So lithium phosphate is the bigger brother of lithium ion batteries, but here is the slight difference. In this you will see the voltage you get here is 3.7. okay, that is the nominal voltage, and here is the voltage you get is 3.2 individual cell voltage. Okay, so let's check the specifications and advantages and disadvantages of this type of batteries. Here is the advantages. So similar to lithium ion batteries, their operating temperature is same. Then life cycle, you get really good life cycle in this. You get around, let's say 5000 plus life cycles in this, and they are going to last a long time, and they are going to be with you forever. Efficiency around 90% of efficiency they can give you. It is there, this type of batteries are have higher efficiency than lithium ion batteries. Depth of discharge is up to 100%. You can discharge this type of batteries to 100%. Repairable, yes, they are repairable. They are available in different design, just look like lithium ion batteries. They are known as 32700, 32650. The lithium ion are known as 18650. Okay, they are available in different design, depend on the manufacturer. In a rectangular shape you get around 3.2 volt, but the AH increases. For example, you can see here the AH is 6000 mAh, but here you can get around 18 AH of individual cell, 18 AH, 12 AH, depending on the manufacturer how they are designing the batteries. So their energy density is really good. Life cycle is really good, around 5000 life cycle you get. Depth of discharge around 100% of depth of discharge you get. Greater than 90% of efficiency you can get. So this type of batteries are used in, even they are used in Tesla, and lots of electric vehicles are using this type of batteries. So you can but the difference lithium ion battery and this type of batteries is the BMS. You have to select a different type of BMS in this type of batteries, because you cannot use 13S to generate 48 volt. So here we have to multiply 3.2 into series, and then we have to check how much voltage, how many cells are required to make up to 48 volt. So in lithium ion batteries we require 13 in series to make 48 volt. In this we require lots of batteries, maybe 14S maybe, to make a 48 volt battery. So here the different the BMS is bit different, but their working is very similar to lithium ion batteries. So let's jump to another type of batteries. I have just shown you to three type of batteries. There is lead acid, lithium ion batteries, and lithium iron phosphate batteries. Lithium polymer I will not be showing because that type of batteries is not used in electric vehicle because of lots of reasons. So here we go. Solid state. Yes, lithium phosphate is used, but lithium polymer is used, but it is very complicated to work with those type of batteries. So let's start with solid state battery. This type of batteries are not used right now currently in the market, but this type of batteries are really good. Okay, they are said to be the kiss of death. Here you can see they are said to be the kiss of death for gasoline and diesel powered vehicles, because if this type of batteries come into the picture, they have if you have this type of batteries in your electric vehicles, what will be the advantages? I will just tell you in a moment. So working temperature is really good, -42 plus 100 degrees Celsius. They will work in extreme cold and extreme hot temperature. Life cycle, you get around 5,000 to 10,000 charge and discharge of life cycle. So really good life cycle you get. Efficiency is around 90% of efficiency. Depth of discharge, you can discharge it to around 100% of depth of discharge you get in this. Repairability, yes, you can repair you can repair this solid state batteries, but just by changing the electrolysis, I mean to say the anode and cathode, there are plates used in this type of battery. So just by changing the liquid and the chemical here, you can actually repair this type of batteries. It is not that much complicated. But here is the small research on this type of batteries. Toyota reveals its solid state battery EVA technology, which claims around 1200 kilometer in a charge, okay, per charge, 1200 kilometers per charge range in just 10 minutes. So Toyota actually tested this type of batteries. They charged the battery just for 10 minutes, and then they got the range of 1200 kilometers in a single charge of 10 minutes. So you can imagine, if you charge the battery 100%, you can easily achieve 10,000 kilometers in just single charge. So here is the biggest advantages of this type of batteries. And here another advantage is reduce the carbon emission of electric vehicle battery by 39%. It can reduce around 40% of carbon emissions. Okay, so you can imagine how good this type of batteries are. But why this type of batteries are not actually get coming into picture, and we are not having this type of batteries in your electric vehicle? The main reason is the gasoline and diesel companies. They are actually running the entire world, and they don't want this type of batteries to be there in your vehicle, because if this type of batteries come into picture, and obviously I'm going to throw all my like gasoline powered and diesel powered vehicles, and I'm going to jump to electric vehicle having solid state battery, and no one is going to buy fuel. So then the oil and gas companies have to shut down. The big countries have to shut down. Because of this, they are going to go to bankrupt situation. That is the reason this type of batteries are not actually being used. They are actually not getting approval from the government to have this type of batteries in the electric vehicle because of the gasoline and diesel. Surely all the people are going to throw their gasoline powered vehicles, and they're going to buy these solid state batteries. I mean to say electric vehicles having solid state batteries, because you are getting 10,000 kilometers of range in single charge. Okay, so here's the, what do you call it as, C rating. Okay, so you can just go through about the C rating, how it is calculated, but just I'm going to show you the graph of a C rating. Based on the C rating, we select the batteries. Okay, let's see. Here is the, here you can see the C rating. Actually, I have written everything here how it is calculated, but I will show you the direct graph of C rating. So one C rating is around, for example, I am having 100 Ah of battery. Okay, 1 into 100 amps of current I am drawing from the battery. Okay, 100 amps of current I am drawing from the battery. So the battery is going to last for 1 hour. So this is how we select. So if I am having a 2C battery, so 200, if I am drawing 200 amps of current, so it is going to last for 30 minutes, and it starts decreasing slowly, but the amps of current increases. I can draw 300 amps of current, 1000 amps of current in 10C. So depending on the C rating, we select the battery. For example, I have to use a vehicle, maybe not vehicle, in a project where high amount of current is required, instantaneous high amp of current is required. So I will be jumping into 10C, so it can give you 1000 amps of current for 6 minutes. So that is how. For example, I am having a big generator, so initially I want to start the big generator for like 5 minutes, then I will jump onto my gasoline powered generator, and then I will be generating lots of electricity. So initially, to run the flywheel, I require high amps of current to run the flywheel, because those flywheels are really big, tons of weight they have, and the motor used to run the flywheel require lots of current. So that time I will be jumping to 5C, or depending on the how much current is required by the motor. For example, it require, let's say, 800 amps of current, so I will be using 10C battery. So it will provide 100 amps of current for 6 minutes, maybe 5 minutes, and then I will cut off the power from the motor and give it to gasoline powered, and then the gasoline powered engine will be powered from the flywheel. So that is how the current rating is selected. So I don't think so you require 10C of battery for my electric vehicle, depending on the conditions. Okay, so let's jump on to battery management system. The BMS is the brain of your battery pack. So without a BMS, you cannot actually make a battery pack. Why? The reason here. So first thing is cell balancing. Let's start with the fourth point, that is cell balancing. In cell balancing, what happened exactly? For example, I am having 3C of battery. Okay, I mean to say 3S of battery series. Okay, so every battery need to be charged to particular voltage. Okay, if any of the battery is under charge, so obviously you are going to overuse that particular battery, and then the cycles of that battery will be lost, and you are going to you have to replace that particular battery. So for example, you can see here the charging cycles of animation of every battery. For example, we have three cells in series. Okay, this battery need to be charged to 4.2 volt, this battery need to be charged to 4.2 volt, and this battery need to be charged to 4.2 volt. For example, there was a mistake in your BMS, and if you are not using your BMS, okay, for example, the middle battery remains under charge to 3.2 volt or 3.8 volt, and these two batteries are charged to 4.2 volt. What will happen is you are going to charge this, you will be discharging these batteries to 3.2 volt, and you are going to discharge these batteries to 2.4 volt, and while charging again you will charge it to 3.8 volt. So after certain cycles, you are going to damage the complete life cycle of these batteries, and then you have to change the battery, or else obviously this is going to the case, you are going to overheat this battery, and then the battery will be damaging your entire parallel connection of the batteries. For example, in parallel you will be having 5 or 10 cells, so entire 10 cells will be damaged, and you have to change the entire 10 cells. So BMS actually take in consideration, and then it charge the batteries to particular voltage which is designed depending on the BMS. So in lithium ion it is 4.2 volt, okay, the full charge volt of the individual cell. Then you have something called as overcharge protection. So in overcharge, what happens is you overcharge your cell. For example, I am having a battery pack, and the maximum charge of the battery pack is 54 volt, and then what happens, you charge the battery, and you don't have a BMS, so you charge the battery, let's say, for 260 volt, and then what will happen is you are actually overcharging the cell. Because of overcharge, your cells will be overheated, and because of overheat, the entire heat will be get trapped inside the battery pack, and that is going to generate a lots of heat. Every battery will generate a lots of heat, and that heat will be keep on adding on, and then it will be going to be like 90 degree or 100 degrees Celsius inside the battery pack, and obviously it is going to catch fire, or else if it is not catching fire, you are damaging your battery to a next extent, and then you will get very low life cycles. So BMS protect the battery pack from getting overcharged from 54 volt to any other voltage. So maximum voltage will be 54 volt, and the minimum voltage maybe, let's say, 32 volt or 28 volt minimum voltage. Okay, that is the over discharge protection. So lithium ion battery is having around 80% to 70% of depth of discharge. Let's consider 60%. So around 60% of charge you can take from your battery, and 40% need to be there in the cells. Okay, that is the reason the BMS are used, and it protects the battery from undercharge. And because of undercharge protection, you are actually protecting the battery from getting damage in terms of life cycles. So we have overcharge protection, we have over discharge protection. Okay, And we have current protection. Current protection, what exactly the BMS is doing in current protection. For example, the motor require 20 amps of maximum current, peak current of 20 amps. And what happens is the winding is get shorted inside the motor. The winding is shorted. What will happen is the motor is going to obviously draw lots of current from your battery. For example, let's say the maximum current was 20 amp. Now the internal winding is short. It is consuming around 40 amps of current from your battery. It is asking for 40 amps, but the BMS is not going to allow more than 25 amps maybe. Okay, it is having a plus range, maybe plus 5% or plus 10%. So it is not going to allow the maximum of 25 to 30%, 30 amps of current to the motor. So this is going to protect your battery from getting discharge very quickly. And if the winding is short of the motor, it is going to consume lots of current. So that is the time the BMS protect your battery and even your motor from getting burnt or getting completely destroyed. So we have current protection, we have overcharge and undercharge protection, and we have something called as cell protection in BMS. So BMS is very important when you are actually making the battery pack. So I have uploaded the videos how you can actually make a battery pack of different voltages of for example, you can see here I have uploaded video on how to make a battery pack of 20s, that is 74 volt, and even 13s of 48 volt, and 12 volt also 3s battery. So here are the advantages of BMS. We have voltage protection, temperature protection. The BMS have a temperature sensor. So what happens is, for example, the temperature is increasing to, let's say, 60 degree, 70 degree. The BMS is going to cut off the power to the motor and it is going to shut down the complete system. So we have temperature protection. Because of this temperature protection, the bike is not going to catch fire. Then we have current protection. So I just told you how the current protection is working. Then we have SOC, that is state of charge. So we can actually have particularly know what is the state of charge of your battery pack. Then we have state of health. So depending on your cells, we can actually see the state of health of the battery pack. Okay, which cell is got damaged. So depending on that, we can actually replace the cell. We have fault slash status. So we know exactly the status of the battery pack and even the fault in the battery pack. If your BMS is having something called as Bluetooth, so you can get all the details of your battery pack to your smartphone, and then you can actually know which battery, which cell is damaged, which cell is undercharged or overcharged, and then you can, depending on that, you can repair your battery pack. So having a Bluetooth in your BMS, it is going to be a big advantage for you. So lots of BMSs are available in the market, and here are the few. These are for lithium ion. Okay, so we have 6S for 24 volt. For example, your motor require 24 volt to get powered and to reach to the particular RPM. Then we have to use 6S BMS for 24 volt, then 10S for 36 volt. Most of the electric bicycles are having 36 volt of hub motor. So the battery pack is going to have 10S of BMS. Then we have 13S. Most of the electric vehicle have 48 volt of battery to power the motor. So 13S BMS is required for 48 volt. Then we have 17S for 62 volt, 20S BMS for 74 volt of battery. Okay, so this is how it is. You can actually directly calculate depending on the requirement of the motor. For example, your motor require 48 volt, then you multiply 3.7 into 13. 13S means 13 series. So you multiply 3.7 into 13, you get 48 volt. Depending on that, you select your BMS. Okay, in the next video, I will be showing you how to calculate the motor calculations, the battery calculation, charge and discharge calculation, range calculation, torque calculation, speed calculation, acceleration calculation. So this calculation, based on this calculation, we are going to design a electric vehicle, and then we are going to jump onto how to do the calculation. I mean to say how to do the connections of the controller and the motor. So I will be teaching you that also, practical knowledge, little bit of that. So here are the few things in calculation. So we are going to consider all the resistance acting on the vehicle. Depending on that, we will select the motor, and then depending on how much range you want, and depending on that, I'm going to design a battery pack. For example, 100 kilometers of range, then you have to calculate depending on the condition, and then I will be coming to a conclusion that what type of battery is required for me. And then we have full load current calculations too, and then we have charge and discharge calculations, how much time it is going to take to charge the battery and discharge the battery. Then we have torque calculations, torque and other calculation, RPM, torque, speed. all these calculations we are going to see. And then center of gravity calculations also we are going to see how to calculate a center of gravity, because while designing a battery you cannot mount the motor. I mean to say, while designing a bike you cannot mount the battery and the motor anywhere you require. So depending on the center of gravity we have to mount everything. Center of gravity is very important, or else while taking turns you are going to crash with your bike. So center of gravity, then we are going to see everything what is required in electric vehicles. So till then, see you soon, have a nice journey.